Before viewing the slides in Unit 2, you may want to consider reading sections 1.4 and 1.12 in the textbook. It'll give you some kind of a background for what we're going to be talking about here. In Unit 2, again, we're not quite into chemistry things yet. We are into a couple topics that are more generally related to, well, to science and to thinking in general. The desirability quotient will be the first topic coming from section 1.4. Critical thinking, what we call the FILCHERS approach, will be coming from section 1.12. In looking at desirability quotient, science comes up with many different things that you can do, science and technology both. Different types of things, advances we can make and things of that nature, but it's important every time to evaluate what the risks and benefits are of implementing that particular science and technology. We define something called a desirability quotient, where a desirability quotient is really simply a ratio. It's a ratio of the benefits of some implementation of something compared to the risks of that implementation. Assigning numbers to those is kind of a whole different topic in itself, but the concept is fairly simple, I think. If you really want to, what you want to have is you want to have high benefits and low risks, which means you want the desirability quotient to be a large number. The bigger the better. Let's look at an example of the use of the desirability here. If it looks like that, it'd be better for me to remove that so that students in the school and teachers are not exposed to asbestos in the airform. So you have to consider the situations that you're in. Let's skip to section 112 in the book, called Critical Thinking. And the basic premise here is how do we evaluate the validity of it says scientific claim, could be any claim. How do we know if this claim might be true? And understand that we can't ever really prove the claim is absolutely true, but we can consider whether it's a valid claim or not, one that can be tested. That's what we need to know. Can we figure this out? The approach we use is one that comes from James Lett back in 1990. The acronym is FILCHERS. Now, in the spelling of FILCHERS, you notice that there are a bunch of capital letters. There are 6 of them. Those are the first letters of the tests that we can use to determine whether a claim is valid or not. Your textbook uses a modification of this called flares. Your textbook leaves out, well, whatever it's leaving out. It leaves out 4 of these, but I decided to go ahead and we'll just do all 6 just so we can see the whole thing in all of its glory. If you click on the link, the blue link there, you should go right to that article if you're interested in reading it. It's kind of interesting to see how this thought process works. What we say is a claim might be true if it passes all 6 of these FILCHERS tests we're going to look at. If it fails any of this, it's likely to be a false claim. Notice that even if it passes all 6 of these, it only says it might be true. Okay, so claims can always be overturned at some point. So, the 6 letters. F stands for falsifiability. It's got to be possible to conceive of some sort of evidence that proves a claim is false. It doesn't do any good to make a claim that nobody can prove is false, because that claim is not testable. You don't get to know. It always has to have a way of being tested to be sure that to see if it's going to be false. The L is for logic. That has to be a logical argument in support of my claim. I can't just do some kind of convoluted logic and think it's going to work out in supporting my claim. Comprehensiveness means that we're going to look at all of the evidence. We're not going to skip any evidence whatsoever. We're going to look at all of it in this claim and base our conclusions on that. Honesty is really related to comprehensiveness, but what honesty says is we're going to look at all the evidence, but we're going to look at it without any kind of bias. We're not going to slant it to come out with a conclusion that we want to come out with. We're going to say, if something tells me that my claim is not right, then I'm going to take it. I'm going to accept that it's not right. The last 2, replicability, is it has to be reproducible. Sufficiency means that the evidence that we have has to be sufficient to establish the claim's truth. Truth might be too strong a word. Establish the claim's possibility of being true. Let's take a look at critical thinking exercise 1 in your textbook. I'll read it to you. An alternative health practitioner claims that a nuclear power plant releases radiation at a level so low that it cannot be measured, but that this radiation is harmful to the thyroid gland. He sells a thyroid extract that he claims can prevent the problem. The question is, how will this claim be evaluated by FILCHERS? Okay. And remember, if it fails any one of these tests, it's done. It's not a valid claim, and we can stop. We don't have to go through all 6. So let's look at this claim. This claim really has, in my opinion, 3 claims wrapped up in it. One is a nuclear power plant emits an unmeasurable level of radiation. The second claim is the radiation is harmful to the thyroid gland. And the third claim is that the thyroid extract he sells can prevent that problem. If it fails any of the FILCHERS tests, then it's not going to be a valid claim. Let's check it for falsifiability first, since that's the F in FILCHERS. And if we look at the three claims, the one is there's a low-level emission, you can't measure it. Well, if I can't measure this low-level radiation, there's no way for me to falsify it. I can't come in and say, nope, took a measurement, it's not true, I can't measure it. So this claim is not falsifiable, and so already that part is determined to be an invalid claim. The second part of the claim is that this low-level radiation, which we can't measure and can't falsify, is harmful to the thyroid. Well, the thyroid has lots of things that affect it. If I can't isolate that low-level radiation as being the cause of thyroid problems, then I really can't falsify the claim that this thing is going to be harmful to thyroid. I really can't do that. If I look at the thyroid extract now situation, he has a thyroid extract that cures it. He's got a thyroid extract that the claim is it cures a problem that may not exist, and we couldn't, and we can't even verify that it causes problems with the thyroid gland, so it's going to be impossible to falsify whether or not this is valid. So all three of those claims fail the falsifiability test right off the bat, and this is not a good claim. This one I saw in an airline magazine, Skunk Ape, sort of a different version of, I guess it's a smelly version of Sasquatch. Some large animal claims to live in Florida, smells really bad. So you can think about this in this sense. You can either say the skunk ape exists or the skunk ape does not exist. Well, notice that only the second claim would be falsifiable, because if I captured a skunk ape, I could prove that claim number 2 was false. Therefore, it would be falsifiable. However, claim number 1 is not a valid claim, because in claim number 1, I can never falsify that the skunk ape exists. Okay, I can't. What do I have to do? I have to prove the skunk ape does not exist. I can't prove it does not exist, because I can't check out every square inch of the universe to see if there's a skunk ape. And so the second claim is actually a valid claim. Doesn't mean it's true or not. Doesn't mean I believe or don't believe in skunk apes. It means it's a claim that can be falsified. If we look at the logic part, and here we say the argument that we offer has to be a sound argument. The logic has to flow. And so, for example, from Lett's article, here's his dogs and fleas one. If all dogs have fleas, okay, we might say, well, Fido has fleas, and then we might follow through and say, well, that means Fido's a dog. Well, the flow is not valid because other types of animals can have fleas. So Fido could be a cat, could be whatever has fleas, beaver, whatever it's going to be. He could be any of those, and so therefore, this is not a logical flow. If you look at the second red statement, all dogs have fleas, Fido is a dog, Fido has fleas, the logic is okay here. Okay? Because if all dogs have fleas and Fido is a dog, then Fido has fleas. That means that, yep, that would be great. But then in order to evaluate the claim, I look at it and say, well, wait a minute, do all dogs have fleas? There probably are dogs out there that don't have fleas. I don't know how many, but there probably are dogs that don't have fleas, which could mean that my first statement is false, and therefore, even though my logic is good, the whole argument is going to be unsound. Comprehensiveness test says that the evidence must be exhaustible. Let's find all the evidence that's related to this. We're going to look at a couple things related to clairvoyant type things, just because that seems to be something Lett focuses in on. It's kind of easy to picture, I think. Suppose someone claims they're a clairvoyant, and they make a series of predictions, and some of those predictions are correct. So they predict that next year 5 things will happen. You get to the end of next year, those 5 things happened. That's great. You say that person is clairvoyant. Now that person may have at the same time made 75 other claims for next year, and at the end of the year, oops, those 75 claims aren't false. I cannot just look at the 5 that were good and ignore the 75 that were bad. Comprehensive means I have to look at all of those. Okay. Then the test for honesty. Okay, so in a test for honesty, what we're looking at is the evidence we have is evaluated without self-deception or bias. Now, honesty and comprehensiveness are kind of tied together. Honesty is going to assume I have all the data. honesty is going to assume that a comprehensive set of data, I've got everything there is that I need to have. But then the question is, once all that data is in place, okay, do I evaluate it without any kind of favoritism? If we go back and look at any kind of bias, so if I want my claim to be true so much that I make excuses for data that doesn't support it, that's not being honest. The clairvoyant example, for example, you could say things like, well, okay, they got 5 claims right and they got 75 wrong, but you know, he was just having a bad day in those 75 days, therefore he still is a perfect clairvoyant. Not very honest. Looked at all the data, blew off a lot of it because it didn't support what we wanted to say. A couple cartoons, I like cartoons. I call this an example of comprehensiveness and honesty a little bit. The guy's sitting around talking about, apparently the premise is that the one in the yellow hat's some sort of a nerd. Last frame, he's saying, well, you're ignoring my vintage 2-pack collection. And the other guy says, nobody but a nerd say vintage. Well, the idea is the guy in the yellow hat saying, you know, he says you're not paying attention to all the information. That's really a comprehensiveness type thing. And even if the other guy did know about the vintage 2-pack collection, he's probably not being honest, although I'm not sure that having one makes you not be a nerd. I don't know. Another cartoon. This is one about the studies that go back and forth and back and forth and back and forth. And so it's really pretty much, you know, this guy wants a job where he creates studies that say whatever people want to hear. Well, the part about critical thinking is you start to learn how to evaluate for yourself without people telling you how to think. The replicability test is, will this happen time after time after time? This is going to happen every time. Here's another sort of a clairvoyant example, parapsychologist example. Gerard Croiset, in the 1900s, thought he had a great ability to solve crimes. In a 50 or 60 year career, he got some right, 3, 4, 5 right. But he also had many, many more opportunities where he was not right. So that means that he was not repeatably correct in his prediction. So it's really hard to say that he had some kind of a special talent for doing that sort of thing. If you made 200 predictions about crimes, you're liable to get one pretty close to being right as well. The sufficiency test is that the evidence has to be sufficient to support the claim. The more absurd the claim is, the more absurd and more comprehensive the evidence is going to have to be. In this example, suppose you come in and you say you're abducted by aliens. You have to have some pretty good evidence that that's going to be true. You have to have, I don't know what you need to have to be able to support that. If you look at, you know, you say, well, I walked to school today, and that's not that hard to support that claim. Somebody might have seen you walking to school or something along those lines. So that's the end of Unit 2. You should now work through the Unit 2 self-assessment. Be prepared to answer questions related to Unit 2 on the first quiz you will take, as well as on the midterm at the end of the semester.